Hi, so today we're going to do the thing where we take a definition that we used to know and we're going to change it a little bit or expand it. So in the past, I told you that the definition of evaluate was to find the single value of an expression. For example, we could evaluate the expression 2 plus 4, which is 6. It's often the same as simplifying, but it's different when you have a variable. For example, x plus 1 can be evaluated if and only if we know the value of x. So a problem might read something like this. So it's telling you to evaluate this expression when x is 2. So you're going to take 2 and plug it in for x. And the value of that expression is 3. Okay? So that we've done before. I don't know that we've revisited evaluating with some of the new rules we've learned about exponents. But I think you could probably put that together. For example, I think you could probably evaluate this expression for x equals 2 as well. You would plug in the 2, the x, you're going to multiply first, or you can distribute the exponent first. It's probably easier to just multiply first. Four and 3 is 7. 7 squared is 49. And that's the value of this expression when x is 2. Okay? So that all should be familiar. What I want to do today is show you that evaluating is not only for expressions. So instead of what you probably have in your notes, find the value of an expression, we're going to say evaluate is to find the value of an expression, term, or equation. And because evaluating a term is really simple, I'm not going to spend much time on it. What we're going to mostly focus on today is evaluating equations, which is a little bit different than evaluating expressions. But just as an example, evaluating a term would be like evaluating 2x if you knew the value of x was 3. It would just be 6. So that's very straightforward. But evaluating an equation is different. So consider the equation 1 equals 1. Now, if I told you find the value of that equation, what would you do? It's not immediately clear, right? So it turns out that equations have values, and those values are either true or false. So in this equation, we can see clearly both sides are the same, and the equals sign means that both sides should be the same, so it's a true equation. So if I said evaluate the equation, you would say true. Okay, so that's simple. As you would expect, if the equation read 1 equals 2, you would say false is the value of that equation. Okay. However, it can get more complicated. So for example, the equation 1 equals x, introducing a variable. Is that true or false? Well, we don't know. It's only true if the value of x is 1. So you would write true if x is 1. Okay? Because it's only true if x is 1, in all other cases it's false. Okay? You could also, if you wanted to be different about it, you could write false unless x is 1. Those mean exactly the same. Okay? So that's still pretty straightforward. Now, it gets more tricky when you start making the equation more complicated. For example, is that true or false? Well, we know it's only going to be true if x is something, but we can't immediately see what x has to be to make the equation true, so we have to use our algebraic steps to solve for x in order to find out what x has to be. So we're going to do the usual things here, combine like terms. To see what x has to be to make the equation true. So in this case, it's true if x is negative 2. Okay? Make sense? Hope. Alright, so getting a little more complicated. Let's take a look at this one. Okay, so is this equation true or false? Can't immediately tell. We're going to have to try and combine some like terms and simplify things until we can see. Okay, so let's distribute this too. And let's add the like terms here, 3x and x. It's going to be 4x minus 6. And now we can see we have two things that are the same thing on both sides. So this equation is unlike the previous equations with variables in that it's true no matter what x is. And I'll show you why. Because if we add 6 to both sides, divide by 4 on both sides, you'll see that it resolves to x equals x. And in number theory, we say that there is no value that is not the same as itself. So any value you're going to plug in for x is going to equal itself. So this equation is always true. Okay? All right, another example. So let's consider the equation x squared equals negative 2. This might seem at first simple, but it is not simple. You have to remember your rules about exponents in order to tell whether this equation is true or false. So one of the things that happens, you might recall, when you multiply a number by itself, is that if that number is positive, it's going to remain positive, and if that number is negative, it's also going to become positive. So that means that this equation presents a challenge because there is no value that you can plug in for x that's going to yield a negative number. And you might recall, I don't know, maybe this is too much, but you might recall the graph of x squared looks like this, and you notice it has no values below the x-axis. So that's just another way to think visually. This function is not going to produce any negative values no matter what. So this equation is always false no matter what the value of x is. So that's a little bit of a trick. You got to remember your rules of exponents in order to figure that out. Okay, and then there are other strange cases. Like for example, you might remember the value of this term is not infinity, nor is it 0, nor is it negative 1, nor is it any real number. We say it's undefined. So if you ever wind up with an equation that has something over 0 in it, it can't equal any number. So for example, like this, this equation is always false because this is undefined. There's no value for x that you can put in that will equal this. So you kind of have to remember that. And on the problem set, there'll be a few other tricky ones involving exponents and order of operations stuff that you may have forgotten. Don't worry about it. One other thing I should just go over because it is on there. I hope you remember, but is how to FOIL. So if you have this sort of situation in your equation, remember the way to do it is to write this out twice. Because what the exponent here means is that this multiplied by itself this many times, so you're going to write it twice. And then you have to multiply this term by each of these terms, and this term by each of these terms. So you're going to get 4 products. You're going to get an x times an x, which is x squared. You're going to get an x times a 1, which is x. You're going to get a 1 times an x, which is x. And you're going to get a 1 times a 1, which is 1. So you can probably see already that these are not the same, but I'll just simplify it a little bit here. Okay, you can subtract x squared from both sides if you want to get rid of it. And subtract x from both sides. Get rid of one of those, and you're going to be left with x equals, let's see, subtract 1, negative 2, I think. So, I think that's right. Yeah, that's good. So, in this case, it's true only if x equals negative 2. So hopefully you already remembered how to FOIL, but if you didn't, that's how to do it. Good luck on the problem set. Yeah, it's all good.